Welcome to this month's PNW Drought Early Warning System Drought and Climate Outlook webinar. My name is Jason Gerlich and I'm with NOAA's National Integrated Drought Information System, hosted by NOAA's National Weather Service and NIDIS, the USDA Northwest Climate Hub, and OCRI. This bi-monthly webinar delivers timely Pacific Northwest drought and climate updates, recent trends, observed impacts, and forecasts. Today's recording and materials will be available on drought.gov. After the webinar, please take a brief survey and help us improve these webinars with your feedback. Today's speakers are Larry O'Neill of the Oregon Climate Service and Oregon State University, and Catherine Fitzpatrick with NOAA's National Weather Service in Portland. There will be time after the presentations for questions. If you look to the bottom right of your screen, you should see 3 squares. That will take you to the Q&A chat box, where we only be accepting questions through the Q&A chat box with Slido here on WebEx. Before we begin the presentations, we wanted to highlight the partners who make this webinar series possible. The Northwest Climate Hub delivers science-based, region-specific information that will assist agricultural and natural resource managers with climate-informed decision-making in Idaho, Washington, Oregon, and Alaska. If you would like to learn more, please see their link in the chat. OCRI is a network of researchers at Oregon's public universities who work with public and private entities to advance understanding of regional climate and climate adaptation. OCRI is administered by Oregon State University and hosts the Oregon Climate Service, the Office of the State Climatologist of Oregon. For more information, please find their link in the chat as well.
Jason, I don't have access to the chat. I'm sorry. We'll need to send them out afterward.
Okay, thank you for letting me know, and we'll make sure to send that out afterward. Thank you. NIDIS was established in 2006 by public law with a mandate to provide the best information and resources available to assess the potential for drought and to better prepare for, mitigate, and respond to the effects of drought. NIDIS maintains a national drought early warning system through the development of regional dues, where networks of partners and interested and affected parties share information and actions that help communities cope with drought. You can stay updated on conditions in your state and area with interactive drought monitoring web pages. Your respective state will be placed in the chat, and we'll follow up with those links again after this presentation. To improve early warning, more precipitation observations are needed. Consider joining COCORAS, the Community Collaborative Rain, Hail, and Snow Network, a nonprofit network of volunteers who measure and report local precipitation. To volunteer or learn more, visit cocoras.org or contact your state coordinator. We will provide those links after this presentation. Understanding your local impacts helps assess drought at state, regional, and national levels. Use the National Drought Mitigation Center's Condition Monitoring Observer Reports, or CMOR system, to submit your experiences with too much or too little water, making your local data directly accessible to drought monitors. Across the Pacific Northwest, there are widespread active drought declarations driven by snowpack deficits, above normal temperatures, below average precipitation, depleted soil moisture, and impacted water supplies. Statewide emergencies exist in Washington and Idaho, alongside active declarations in 21 of 36 Oregon counties. Again, respective links, if you'd like to learn more, will be provided after the presentation. Register today on November 2nd through November 3rd from 9 a.m. to 12:30 p.m. Pacific Time will be the Oregon-Washington Water Year 2026 Recap in 2027 Outlook meeting. The meeting will be held virtually on both days. In order to attend, then please register. This meeting will review climate impacts from the 2026 water year, including December flooding, low winter snowpack, developing drought, and above average wildfire seasons. An open group discussion will be also facilitated on local mitigation actions as well. Additionally, forecast experts will outline expectations for 2027 and the impacts of this year's very strong El Niño. If you want to receive the recordings of today's webinar and other pertinent information for the PNW dues, please follow the link that we will provide to you all at a later time. Please allow, if you'd like to continue to keep up to date with NIDIS webinars and the latest decision-making information that NIDIS can provide through drought.gov and a lot of our partner and integral collaborations across the Pacific Northwest. Lastly, I want to make sure to say a big thank you to all of our speakers who will be presenting today. You can see their emails here on the screen. And thank you to all of our partners whose logos are on the screen as well, who help provide the input for this webinar to ensure that the timely and accurate information is delivered. This webinar was truly a collaborative effort. Our next webinar will be on October 26th, so please mark your calendars. Thanks again, and now Larry, I will turn things over to you. Larry, if you're presenting, we cannot hear you yet.
Okay, there you go. Sorry about that. Good day to you all. My name is Larry O'Neill, and I'm the state climatologist of Oregon and the director of the Oregon Climate Service. And today I'm going to talk about, give the climate recap and current conditions update for Oregon. And then immediately preceding this, I'm also going to give a separate presentation on some of the emerging impacts that we're seeing from drought conditions from this spring and summer. And it's a little bit of a new format that we're going to try out to better kind of assist understanding what these conditions, like the physical conditions, mean for drought. So conditions over the last 90 days have been a little bit variable across the Pacific Northwest. And so this covers basically the dog days of summer from the end of June to the middle of August. And basically over a lot of the Pacific Northwest, it's been much warmer than normal with temperature anomalies on the order of about 2 to 4 degrees Fahrenheit, especially over eastern Oregon and southern Idaho. What's been really nice on the west side of the Cascades in both Oregon and Washington is we've been actually about normal for temperatures or slightly cooler than normal, which has really kind of ameliorated some of the drought impacts that we're seeing on the west side. However, we've been much drier than normal across most of Washington and Oregon, where we've received very little monsoon precipitation, or the little bit that we've gotten from thunderstorms has been kind of spotty. Over Idaho, however, much of central Idaho has gotten above normal precipitation over the last 60 days, driven by several pulses of monsoon thunderstorms that have come through the region. So it gave some very beneficial precipitation and prolific lightning across the region. So these recent conditions only tell part of our drought story. While some areas have received beneficial summer precipitation, most severe drought areas entered summer with large accumulated snow and moisture deficits. And to show this, these are conditions since January 1st of this year. And basically, we've been really warm and dry throughout the Pacific Northwest with hardly any exceptions. And so this winter was one of the warmest that we experienced in the Pacific Northwest, including tied for record high in Oregon and Idaho. And temperature anomalies have been over, somewhere between 3 and 5 degrees Fahrenheit throughout this period. And so obviously that, as we've talked about in previous webinars this year, in conditions updates, this high temperatures really impacted our snowpack and our water supply and drought conditions. Not only has it been warm, it's been really dry. So much of this, most of the Pacific Northwest has been under 90 or 70% of normal precipitation for this time of year. And so this includes January and February when we get the bulk of our precipitation. And a couple areas to really highlight are up in north central Washington, which is below 50% of normal, and then in southern Idaho, which has received less than 50% of normal as well. Most of Oregon has received less than 70% of normal, and so this has kind of exacerbated the drought conditions during that time. And just going to precipitation again, so less than 50% normal in some places and 70% in others. Where we see the darkest browns here, this is below the 0th percentile. So these are all-time records since January 1st. So this is in kind of northern Washington, in quite a bit of area in central and eastern Oregon, and then in parts of southern Idaho here. And so just looking at just statewide rankings for January through July, Idaho has experienced its 19th driest start to a calendar year since 1895. Oregon is the 9th driest start, and Washington is the 27th driest start to that calendar year. So drought conditions were really driven not only by the lack of snowpack, but also large precipitation deficits that have accrued across the landscape. And for temperature percentiles, we're kind of set records for the start of the calendar year, especially across the southern part of our domain in both Oregon, Idaho, and western Montana. So Idaho has experienced its 3rd warmest start to a calendar year. Oregon is also tied for its 3rd warmest, and Washington's experienced its 6th warmest here. So basically, this year has really started out warm and dry across the region. So this, not only has we received precipitation deficits, but these warm conditions have also exacerbated evapotranspiration from the landscape. And so this is basically a loss term where water can evaporate from the soils and the landscape and basically be lost to the atmosphere. And this just shows 2 maps of the mean evapotranspiration percentiles for both the water year since October 1st on the left, and then the last 6 months on the right. And both of them show a very similar story in that much of the region has experienced abnormally high levels of evaporation. So basically what precipitation did fall was evaporated more quickly. And so this really exacerbated the dry conditions across the landscape. And this really compounds the precipitation and snowpack deficits that we accrued during the winter and spring. And a couple areas just to highlight here are in central Oregon, in this line that bisects southwest Oregon with northeast Oregon, where we've seen some record high evapotranspiration rates in a lot of the region. And this has really also contributed to wildfire risks in the region as well, because it dries out a lot of the fuels, especially the fine fuels, much quicker than normal. And then also in southern Idaho here, where a large portion of the Snake River plain has received abnormally high evapotranspiration and in some cases historically high. And with those high evaporation rates and low precipitation values, it's no surprise that we see very dry soils throughout the region. And this is just one map showing the percentiles of it. So the darkest red values are near record low soil moisture for this time of year. And then the warmer colors in general just show drier than normal soil moisture. And so across the Pacific Northwest, we're seeing these lowest soil moisture values, again, in Oregon, in this kind of that line bisecting southwest and northeast Oregon, upper and large portions of north central Washington, Idaho, and then into southern Idaho as well here. And now, now that we've gotten far enough in the summer, we're seeing a lot of these poor precipitation, high evaporation, and poor soil moisture conditions rapidly. We're seeing those in these actual stream flow and water supply here. So in much of Washington, Oregon, and Idaho, we're seeing many stream flow gauges that are at or near record lows, either daily record lows or in some cases all-time record lows. And these current low stream flows were signaled many months ago. So once we knew that the snowpack was historically bad, we knew that stream flow conditions were going to be similarly as bad as we got further into summer and into early fall. And wherever you see these dark brown, the darkest brown here are in the lowest percentiles. And where you see the exclamation points are gauges that are at daily or all-time record lows. And so you kind of see them scattered all throughout Washington, Oregon, and Idaho here. And in the impacts discussion that I'll have after this conditions update, I'll kind of summarize some of the impacts that we're seeing from those really poor conditions. And so in the U.S. Drought Monitor, we give each state gives weekly updates to the U.S. Drought Monitor, and so we've been trying to keep on up to date with conditions as they are evolving and as we see them in the indicators. So at the time of our last webinar, which was in mid-June, around June 23rd, this is what the drought map looked like. And for those of you unfamiliar with this drought map, the progressively darker colors indicate more severe drought conditions. And so D4 is exceptional droughts, that's a historic drought. D3 is extreme droughts, D2 is severe, and then we have D1 was moderate drought. And so we went into summer with pretty widespread drought conditions over much or most of the Pacific Northwest. And since that time, this is the latest drought map that we have right now. Both D3, the extreme drought, and exceptional drought has increased in coverage, particularly in Oregon, and also into Washington as well here. So basically, and then some of the summer thunderstorms that central Idaho received, they received some beneficial precipitation and some short-term improvements in drought severity in that region. And so this just shows the change in the U.S. Drought Monitor over the last 8 weeks between those two time periods. And so much or most of the region has had degraded in drought severity by at least one class, and in some parts have been 2 classes as well, including a lot of Washington and some parts of Oregon here as well. While we saw a little bit of improvement in central Idaho due to those beneficial summer thunderstorms here. And I'm going to end this webinar just by giving some of the more specific drought indicators that support the depiction of both D3 and D4 in the U.S. Drought Monitor, so that we can kind of give an understanding why these conditions are so severe and what specific mechanisms led to those degradations. So for Oregon, we have D4, so this is exceptional drought and the worst drought classification. It's meant to be kind of more of a historical type of drought designation. So you need to, a lot of these drought indicators need to be the driest we've ever really seen them in the historical data records. So this D4 is, the epicenter is around Grant County in Oregon. So that's Grant County right there, but it also touches upon Baker and Wheeler counties as well to an extent. And so this D4 represents about 3.9% of Oregon's landmass. It's the second time that Grant County has been designated D4 in the US Drought Monitor era, which started into the year 2000. And this is just a time series of Grant County's drought depiction. So it starts in 2000 on the left and is up here through current time right now. And the other time that it was in D4 was in this period between 2021 and 2022, when Oregon was going through arguably its worst drought period in its recorded history as well. Otherwise, it has not seen drought that severe before. So one of the big indicators right now are hydrologic. It has to do with the stream flows and reservoir levels within the upper John Day River Basin. And this just shows one hydrograph from this region. So this is the North Fork of the John Day, and there are a few others that are like this. And the colors here represent, so from brown to blue, it represents basically the historical range of observations. And the y-axis here, what this represents is just the flow volume per unit time that flows through there. So it's cubic feet per second. And the black trace here just shows the evolution through this year. So the peak was back in about April. So there was a bit of a snowmelt peak in here and some rainstorms that we had in April and May. But since then, it's just fallen off a cliff due to the very dry conditions in the landscape. And now we're sitting at near, so definitely in daily record lows throughout much of the summer, but also near an all-time record low currently right now. So this is kind of one indicator showing that we're at historic conditions there. So that supports the D4. The soil moisture is in the driest second percentile. And I forgot to put that figure on there, but we saw the map earlier from the soil moisture map that the region was in this dark red color. And then the snowpack in the surrounding mountains. So in Grant County, it's surrounded by the blue, it's within the Blue Mountains. And there are a lot of these snow tell stations. And what this map shows is basically the rank of the snowpack amount on April 1st, and the snowpack amount is the snow water equivalent. And the ones here indicate that it was the lowest snowpack that they ever recorded, and most of these stations were around 1981 or in the early 80s. And then 3 is the third lowest here. So a ring around the John Day Basin, here into the Ochoco Mountains as well in Crook County. These are all set or were near or set all-time record lows for the amount of snowpack they received. And then a drought indicator that we use to look at the relative importance of precipitation versus evaporation, which is called the SPEI, or the Standardized Precipitation Evapotranspiration Index. It's below -2 on timescales extending out to 2 years. And this is just a map showing the 1-year SPEI. So this is what's happened between precipitation and evaporation over the last year. And these colors are the same as the US Drought Monitor category. So everything below -2 corresponds to D4 or exceptional drought in the US Drought Monitor. And we see that much of Oregon here has, and definitely within the D4 region here, has those sort of conditions ongoing. And then the evapor demand has been above the 98th percentile over the last 180 days in this region. So we see here. And so this just indicates that evaporation has been extremely high and probably historically high within the region. So there are a lot of indicators that support this. Within Idaho, Idaho also has this big spot of D4. It's through Wahi, Twin Falls, and Cassia counties in southern Idaho up to Salmon Creek, southern Idaho. So D4 covers about 7.8% of Idaho. And it's the second occurrence of D4 in these counties during the USDM era. And I'm just showing the time series here for Wahi County. So right now it's been in D4 since about early February. The other occurrence was in 2003, which was a really severe drought in much of the Pacific Northwest as well. Otherwise, it has not had that at all since 2000. Snowpack was lowest on record. You had the higher elevations of the basin, which feed into this river plain, the Snake River Plain. And so the same, this is the same ranking map of the SNOTEL SWE across southern Idaho. And most SNOTEL stations here had recorded their lowest snowpack on record here. And so there just wasn't enough runoff from the snow. This is a very strongly snow-dominated basin. And so without that snow, there was very little water. Daily and all-time record low stream flows in the region. So I took one example from Bruneau River in south central Idaho. And right now it's at its all-time low right here. And it's been at its daily record lows since end of May as well. And they've had periods within April and May where there was just all-time record lows. So it's just really gives evidence of that poor snowpack and poor snowpack runoff. There was very little of it when they should have had a lot. And then the 1-year SPEI. So there's a variety of timescales here, but the 1 year shows this the best. So it's just a combination of poor precipitation and a high evaporation within the watershed. And then they also have had low soil moisture levels in much of the basin where the D4 covers that correspond to that depiction. Finally, I want to go to Washington just to show their extreme drought indicators. So D3 here in Okanogan County and north central Washington. And so it represents about a little less than 1% of Washington. It's the 4th occurrence of D3 in this county in the USDM era. And so right here, we're here. Last time D3 was present in the county was last year when about half the county was designated that. There was the 2021 drought where it was actually D4 for a short period of time. And then before that, it was in 2015, right within our last very strong El Nino event. Stream flows are near record lows or generally below the 5th percentile. So the 5th percentile is generally the cutoff we use for determining D3. So within that. So this is one of the rivers, I can't say the river name, sorry. But it is right now near its daily record lows right here. And so this dark brown here is within the lowest 5th percentile. And so this is, and it's nearing its daily record low too. And without precipitation, it may flirt with its all-time record low as well going into fall. And then the 1-year SPEI, so that drought indicator between precipitation and evaporation indicates D3 or D4 conditions are present within the area. And so here's the 1-year timescale here. And what's really interesting is many of these places within central Washington, this is their 4th year of drought, a drought occurrence here. So there's also multi-year indicators that we could use for that, but at least on the 1-year time scale is sufficient to to kind of evidence for this as well. So anyway, these are my key points. The Pacific Northwest has been warm and dry, and it's superimposed on a multi-year drought in parts of the region, especially in central Washington, but also parts of Oregon and southern Idaho. And the historically poor mountain snowpack has compounded our precipitation deficits. And then near record low stream flows, we were expecting them. They were long forecasts, and now they're here. And this is causing severe hydrological drought and big impacts, as I'll talk about in a few minutes. And then we've had a little bit of drought intensification over the Pacific Northwest. And then finally, the most severe areas, all the areas really, but the most severe areas of D3 and D4 are supported by a multitude of indicators. And so it's not just record low snowpack, but it's the long-term precipitation and evaporation deficits and extremely low soil moisture. So thank you. That's going to conclude the conditions part of this program. And now I'm going to share a conditions update or an impact update here. So this is kind of something we're kind of playing around with. When we get into kind of the summertime period, this is when we're really starting to see the really big adverse impacts from a lot of these conditions what I've just highlighted. And so as we're getting these in real time, we wanted to kind of highlight these a little bit more specifically. And this was kind of an effort from our drought layer early warning system and a number of other partners who I've listed here, and I've probably forgotten a few. So if I did, I apologize. But this is kind of this, a collaborative effort to try to gather impact conditions and try to report them as they occur. So the dominant drought impact types that we've observed so far this in the Pacific Northwest, big one is water supply, wildfire impacts, and agricultural production, and then fish and ecological impacts, although I won't have time too much today to talk about those. But we are observing some of those as well. And I'm going to show some examples in this presentation that highlight some of the most significant reported drought impacts to date. And these do not represent the full extent of impacts that are occurring across the region. Some of it is because drought impacts still have yet to rear their ugly head, but also because in real time, it's sometimes really hard to know what's going on all across the region here. But I think we've observed enough that we can start to say, we could start to kind of paint a picture of how bad the drought is right now. So first thing I'm going to do is talk about water supply impacts. And so this just shows a map of the current U.S. Drought Monitor. And then I put some of these icons on to represent specific regions that we have drought impacts right now. These include low reservoir storage with the icon that shows a dam. The water shortages in the spigot, groundwater or soil moisture deficits, and then low stream flows. And so these aren't all the places where these are occurring, but these are some of the more dominant ones that we've been observing. And I'm not going to talk about every single icon here, but I'll just kind of give a little bit of a flavor, brief summary of what we observed throughout the region here. And so water supply impact summary, we're seeing a very low reservoir storage across the Pacific Northwest, where we're substantially depleting our reservoir storage. And now we're getting into kind of the later part of August and September. And so reservoirs are being emptied out, and there's little hope for carryover into the next water year. And then, as I mentioned earlier, we're seeing record low stream flows occurring in all 3 states. And I put some examples of the rivers that we have stream flow gauges that are either reporting record lows or daily record lows or all-time record lows throughout each state here. And I'm going to go just state by state just to summarize some of the ones we've experienced, because that's kind of how we've gathered the impacts reports is from our state partners. And so I'll start with Idaho. And the main story there is that there are irrigation shutoffs and little carryover expected into next year, especially across the southern Idaho and the Snake River Basin. The Salmon River Company turned off irrigation on June 10th, followed by Big Wood on July 8th. And then the upper Snake River reservoirs are currently at 22% of capacity and 41% of average. And there's no carryover expected through this fall. And major canals are expected to exhaust their storage and cease deliveries around September 10th. The East Snake Plain Aquifer, which I've shown in this map here, so it's the Snake River Plain, and then kind of the East Snake River Aquifer is the east part of this. And right now they're experiencing near record low groundwater levels, many wells at record lows, and major springs are currently have water volume that is less than the 10th percentile, including Box Canyon, Briggs Spring, and Devil's Washbowl. In Washington, this is their fourth consecutive drought year, and so it's becoming kind of an old song. Each year we're seeing these same sort of impacts here. One big one is that the Spokane River has now run dry, and this is 2 weeks earlier than before, and the second time it's happened. And this is early August that's happening, so it's pretty concerning. So record low street levels across the state. One specific thing is in the Yakima Basin, pro-ratable water users are receiving about 58% of their full allotment. And this basin includes the Rosa Irrigation District, which supports over $1.5 billion in agricultural revenue annually. Some small utilities have been trucking water, and for instance, in Clallam County, the Public Utility District, and this is interesting because this is on the Olympic Peninsula, which is right now in moderate drought. So these drought impacts are being felt acutely across the state. And for August through September, the River Forecast Center forecasts are most stream flows are below 75% of normal, and with even some that are less than 5% of normal. So basically the tap is turning off, and so this really supports the statewide drought declaration that's in effect in Washington. The Columbia River is a notable exception.
Barry, about 4 or 5 minutes more, please.
Okay, thank you.
Thank
And
you.
so for Oregon, we're seeing most stream flows are below 30% of normal with new record lows. The Oregon Water Resources Department has reported that earlier than normal regulations coming across the state, and senior water rates were regulated for the first time ever. Reservoir storage is rapidly declining, especially in central and eastern Oregon. Already Union and Baker County reservoirs are near empty, Thief Valley, and carryover in larger reservoirs in 2027 is likely to be non-existent to very low all across central and eastern Oregon. And there's little surface water left for some producers in Klamath and central Oregon. And we've had some reports of aquatic vegetation that are clogging water equipment in the Klamath Project and Crooked River. And then in the Umpqua Basin in southwest Oregon, producers are foregoing irrigation and harvesting of crops in that area. So one of the biggest, most visible impacts of the drought has been the wildfires. And so this just shows kind of where some of the large wildfires are occurring across the state. And most of them are occurring where we have drought conditions here. So we both have large wildfire activity and wildfire smoke. And drought is just but one driver of wildfires. And this year, drought conditions have combined with both critical fire weather and multiple lightning outbreaks to produce one of the Pacific Northwest's most active wildfire seasons in memory. And this is just one thing to remember is that last year in summer 2025, we also had significant drought conditions, but wildfire activity was not nearly as widespread. So it just goes to show that you need more than just drought to get wildfires, but they make it more likely once you do. And Oregon has, each state has declared state of emergencies due to wildfires. So declarations started in June and went through August in all 3 states. And so far, preliminary estimates have about 3.5 million acres have burned in the Pacific Northwest, led by Oregon's 2.4 million acres. And so this support surpasses by far the previous record of 2 million acres burned in 2024. And we still have roughly a month left in fire season here. Washington is also getting close to 1 million acres, which is quite notable. And the 2.4 million acres in Oregon represents about 4% of its total land area burned in 2026, which is a pretty sobering statistic because most of that burns just within about a month period. of time. And so the wildfire smoke produced significant health impacts. So this just shows a satellite image of the wildfires. All throughout here. So this was on August 5th. And this is the Willamette Valley, where most of the Oregon's population lives down here. But in eastern Washington, all throughout basically our Pacific Northwest region was impacted significantly by wildfire smoke. And in Portland's metro area, it was wildfire smoke on August 6th produced the second highest AQI ever recorded there in the Portland metro area since 2001, as monitored by the EPA. And this was second only to the Labor Day 2020 wildfires. And according to the Oregon Health Authority, they saw a spike in emergency department visits due to wildfires and wildfire smoke and heat exposure between late July and early August. And of course, Spokane, I mean, we have these all around here, but I just wanted to show Spokane that it also, because of the fires that were burning there, they also received either unhealthy or very unhealthy air quality for about a 10-day period in late July and early August. And of course, the Spokane complex of wildfires was one of the most destructive was the most destructive. 67,000 people evacuated, 931 structures destroyed, 10,000 customers without power, 1,100 firefighters assigned to it, and more than 10,000 acres burned. So drought didn't cause these ignitions, but they created the conditions with exceptionally dry vegetation fuels to favor rapid fire growth and extreme impacts once those fires started. And finally, I'll end with agricultural production. So we won't know the full scope of impacts until the end of the growing season, but we have some preliminary data that suggests that this drought will be in fact impactful for it. USDA has secretarial disaster designations in effect across much of the region, so it provides eligible producers access to federal disaster assistance. And basically, the agricultural impacts, water availability, irrigation, some of what I've talked about before, ending irrigation deliveries early. Producer responses, so irrigators have chosen not to irrigate, and producers have chosen either more drought-tolerant crops or to leave their fields fallow, and much of Southwest and Central Oregon here. And livestock and forage, there's a conservation relief reserve program administered by the USDA Farm Service Agency that has an emergency haying and grazing program, which allows for more grazing opportunities and foraging opportunities for livestock here. And this map kind of shows in the dark green all the regions that are currently in that designation that have current approved emergency haying and grazing here. And so the agricultural financial losses are beginning to emerge here. So this is just showing in each state, Idaho, Oregon, and Washington, some of the drought-related impacts, which would be in these orange bars. So failure of irrigation supply has cost Idaho, for instance, at least $20 million financial in losses due to crop insurance indemnities that are being paid out. And these provide an early measure of realized financial impacts, but losses remain preliminary because many claims will be processed until after the growing season. And it's sometimes hard to separate out drought-related impacts from others. So these are the basically key drought impacts that we've experienced thus far. And I won't read these now, but I'll be happy to answer questions about them should they come up. So thank you.
Thank you, Larry, for that very in-depth presentation, going over our current conditions and our impacts. Thanks again. Next, we'll have Catherine Fitzpatrick with NOAA's National Weather Service present. Catherine, please feel free to start sharing your screen.
All right, can you guys see my screen? Or not yet?
All looks good. Thank you.
Okay, great. So my name is Catherine Fitzpatrick. I am a hydrologist at the Northwest River Forecast Center. If you have any questions during or after the presentation, or I guess after, you can email me at catherinefitzpatrick@noaa.gov, or you can email any of our hydrologists on the water supply team at this email listed right here. Okay, so I'm just going to go over a summary of the water year to date, much of which Larry has already covered, so I'll try to keep it short. On the left over here, this diagram is our runoff for the water year. So green is going to be normal, 100 would be percent normal, and then blues will be above normal over here in Canada and the upper Columbia, and then reds are going to be below normal runoff. So much of the basin, the northern part of the basin, has seen normal to above normal runoff for the water year, and the southern part of the region has seen below normal runoff. Coupled with overall temperatures for the water year, so October 1st to present, we've seen positive temperature departures of 3 to 6 degrees above normal for much of the region. And that means that we didn't build a great snowpack over the winter. This diagram in the middle here is snowpack peak as a percent of average. So basically the highest the snowpack got all season long, and how does that compare to peaks of previous years? So the red is below 25% of normal, and you can see that almost the entirety of the state of Oregon is below 25% of normal, and some record low snowpacks. And then Washington as well is below normal in these warm colors. The only exception is Canada, where we actually saw one record highest peak snowpack for this year. And then over on the right is our water supply forecasts. Once again, the warm colors are below normal, percent below normal, and then green over here in Canada and the upper Columbia would be normal water supply. And note that our water supply forecasts are for the entirety of the April through September period, and we're in August now. So much of these forecasts are based on observation at this point. As another summary of the precipitation for the water year, we saw above average in these select locations here in the western Cascades and Washington, and over here in Montana as well. We did see a lot of precipitation throughout the water year above normal, and then in southwestern Oregon was below normal. Seasonal temperatures really warm throughout the entire region, especially in southern Idaho. Our current conditions over here on the left is current monthly precipitation summary for August. The reds show Oregon and much of Washington as below average for this period of August up until now. And then we did actually see some convection through southeastern Idaho and Wyoming and central Idaho. So that is above normal for the month of August. Temperatures remain very warm for the month. And then over here, these three diagrams are our 10-day QPF, our precipitation forecast for the next 10 days. So this here is showing little precipitation, mostly just in the Olympic Peninsula, about 2 inches in the next 10 days. The central diagram right here is how that QPF compares as a percent of climatology compared to this time of year in a normal year, essentially. So the red means that it's lower than average for climatology, and then the cool color up here in the Olympics is above average. And this diagram on the right is the deviation from climatology in inches. So all of these are percents of normal, but 130% of normal may sound impressive, but in August, that's going to look like 0.25 inches above normal. So just to give you some context, is even though you might be getting some convection here in Idaho, it may just be about 0.25 inches more than normal for August. These are, on the left is our water supply forecast for the whole region, and on the right is accumulated precipitation for the water year. And so what I want to show here, I want to zoom in on the upper Columbia Basin. The green shows these normal to slightly below normal water supply forecasts for the upper Columbia. And on the right, our accumulated precipitation through the water year. The blue is going to be this year, and that's 2026. The dotted line is the 30-year average, and the other colors are previous years. So our water supply forecast at Grand Coulee for the Upper Columbia Basin is about 92% of normal, but the accumulated precipitation all year has been well above normal, 109% of normal. And that's just further evidence of our snow drought, or that most of the precipitation that we got, in other words, it fell as rain, although we expected it to fall as snow, except for the very northern reaches of Canada. So we did have a healthy snowpack up here in Canada, but not for the rest of the region. So this is the Snake Basin that I'm highlighting, everything above the Lower Granite Dam. Right now, Lower Granite is 68% of normal for our water supply forecasts, although the precipitation was 93% of normal. So we did get precipitation up until about May that tracked along our 30-year average. But come springtime, when we expected snow melt from the snowpack that didn't build, that's when we started to fall below the 30-year average. And that's continued through the rest of the season. The Columbia Basin as a whole, so at the Dalles over here, is about 82% of normal, and precipitation has been 93% of normal for the entire basin. So just to recap, we saw a healthy snowpack in Canada, but everything below that, although we received a normal to above normal amount of precipitation, it was not stored in the system and has been lost to the system, which is why we're seeing these below average water supply forecasts. So this diagram here is just highlighting some of our points of interest throughout the basin. Mostly what I want to draw your attention to on the right is runoff. So the amount of water that we saw through the system in the water year, above normal in a lot of the Upper Columbia. And then as time has passed since May 6th, we're seeing a negative trend throughout. A lot of that is showing that we had a December atmospheric river that impacted a lot of the region. So we did see these really high numbers of runoff for the water year. And then as time has passed, precipitation and runoff have not kept up with our percent normal or our average. And so that's these negative trends, lower and lower. We see the same in the Snake Basin. They were already low as a percent of normal, and they've only gotten lower as conditions remain dry. This is our natural observed runoff. The big difference here is water supply. Adjusted water supply is the adjustments that we make for historical water management, especially as it relates to the Columbia River Treaty. Natural observed runoff is going to be the basin conditions if we were to take out anthropogenic use to the best of our ability, to the best that we can model in our CHIPS configuration. So natural observed runoff, we're seeing much of the same trend. We saw a normal, percent normal throughout Washington and the northern parts of the basin, and the trend has only gotten more negative since May throughout the summer months. In some places, especially these snow-dominated basins like the Methow and the Yakima and the Okanagan, that lack of snowpack can really be seen in the summer months as that snow melt that we expected didn't come to fruition. So here is water supply, adjusted water supply. So that would be the adjustments that we do make for historical water management. Up at Mica and Duncan and Queens Bay, all of these Upper Columbia healthy water supply locations, we do see relatively normal water supply here, and then down in the Snake, we're seeing much lower numbers as a percent of normal. I will point out that a couple of locations here, American Falls and Lucky Peak, we have seen a positive increase since April. I think some of that is just due to the small amount of convection and that reservoirs are very low right now. So a 12% increase of what's in Lucky Peak is going to be easier to achieve than if it was completely full. Natural water supply forecasts. So this is basin conditions. If we took out anthropogenic use, we've seen negative trends as well throughout the summer. So a lot of these are already extremely low. The Dungeness over here is 46% of normal. It sticks out to me. Crooked River near Prineville, 6%. So water supply is quite low throughout the region. And here, to give you perspective, I have included these water supply forecasts through the region. And on the right, I have a ranked percentile. And so what that is basically if I were to put water supply years in order of lowest to highest water supply in our period of record, which for most locations is about 78 years, although it can vary from point to point. Some of these areas here in Washington rank as the #1 lowest water supply year or #2 lowest water supply year in our period of record. And you can see these low numbers throughout most of Oregon, Washington, and southern Idaho. I've highlighted some points of interest as well. The Skagit near Mount Vernon is one. It's located right here in Northwest Washington. I've highlighted this point because we actually issued a record flood forecast in December during the atmospheric river. And now it is ranked the 3rd lowest water supply year in its period of record. It's at 67% of average. And this diagram at the bottom here, I know this is a bit of a busy slide, but these are all of our water supply forecasts. We have a couple different methods that we calculate water supply, but we're using the ESP10, our 10-day QPF forecast. And this is our water supply forecast throughout the year. So on the left is volume in kiloacre feet. The green line is the 30-year normal of water supply, and then the x-axis is in time through the water year. So you can see these oscillations. December, we saw that atmospheric river input of water into the system, but then because it wasn't stored as snow, and this is a snow-dominated basin, water supply fell below normal and has remained there throughout the season. And then as we got into snowmelt season, April through May, it's only gotten lower and lower. You can also see it here in our monthly runoff, the observed runoff in blue versus green, which is the 30-year average. In December, we had way above average runoff, but it wasn't stored and it was lost to the system. And then we saw that absence here during our snowmelt season. I've also highlighted American.
Catherine, about 5 more minutes, please.
Thank you. So the American Falls Reservoir is at 25% of average, and it's ranked the 8th lowest water supply year in its period of record. We can see that same trend where we saw water in December through January, and then as we expected snowmelt, that did not come. It's just gotten lower and lower. Here, I mean, it's best seen here in the monthly runoff diagram. All of this green is what we would typically expect to see in our snowmelt season, and we obviously didn't get any of that. Here is the Upper Snake Basin system capacity diagram, courtesy of the Bureau of Reclamation. Right now, the American Falls is at 10% of full, and the entire system is at 19% capacity. And just to put that in perspective, I included this diagram also from the Bureau of Reclamation. This red line is its 30-year average of where it would be this time of year. And this is where we're at. Now, I have to caveat this by saying that reservoir management can oscillate due to like fish passage, and so I can't speak to the way that reservoir operators are managing their reservoirs, but it does mean low carryover for 2027. Grand Coulee, I've highlighted this point just because the Upper Columbia Basin is doing relatively well in comparison. We see that throughout the year in these water supply forecasts. We did have good snowpack building in the Upper Columbia, and we see April, May, it stayed above normal, and then it's just only recently dropped below the 30-year average. And that is in part due to the above average temperatures that melted out the snowpack, in some cases 10 to 40 days early. And so that water was lost to the system when we did expect it to remain there. And you can kind of see that in the monthly diagram as well. June, July were a little bit below the 30-year average, mostly because that runoff left the system before it typically would. And then lastly, the Dows. The Dows is at 82% of normal. That's ranked 14th lowest in water supply years for its period of record. I have the numbers over here. And that's in part because we have its combination of the Snake and Upper Columbia basins, which are both running slightly, Upper Columbia is running slightly below normal and the Snake much below normal. Our long-term climate prediction center outlook, the seasonal prediction, so the next 3 months, precipitation will remain below normal and temperatures will remain above normal. We have a 90% chance of a very strong El Nino. There is a negative correlation between the runoff at the Dalles and an El Nino, meaning that lower runoff is associated with El Nino for the region or at the Dalles. However, it's a very weak correlation. And I will caveat that by saying that we do not include CPC outlooks in our streamflow predictions. So the main takeaways, the past 2 months, precipitation observed runoff has been lower than normal, except in select parts of the northeast and southeastern edges of the region. Monthly temperature anomalies continue several degrees above normal. The water supply volume is below normal, except for Canada, and outlooks remain dry and warm with a 90% chance of a very strong El Nino. El Ninos are associated with snow droughts for our region. And I'll take any questions.
Excellent. Thank you, Catherine, for that very in-depth presentation and a closer look at some of the stream flow anomalies that we're seeing here across the region. With that, our apologies for running a little long here, but we hope that you gained a lot of benefit, useful information from this in-depth presentation on conditions, impacts, as well as our seasonal outlooks. We will not, unfortunately, apologies, have time to get to some of the questions that we've seen here in the chat, but we have saved them and we'll do our best to follow up as well. As you can see here on our screen is all of the respective emails from those who presented today, as well as all of our integral partners that made this webinar possible and provided a lot of the very specific, in-depth information to help provide informative decision making. So please do not hesitate to reach out to any of the emails that you see on the screen. If you have specific questions, we'd be more than glad to follow up. Thank you to our speakers again for all of your great presentations and all of the great information that you provided. Thank you to all of our attendees for attending this webinar and continuing to make these webinars a success and useful to the general public. With that, we will conclude this webinar. Again, please do not hesitate to reach out if you have any specific questions to the emails on the screen. With that, please take care and have a wonderful rest of your day.